Okay, this is the lecture for that's going to cover the first homework, atomic sentences and the basic grammar of predicate logic. Predicate logic is the very simplest of logical systems, and it's the one we're going to be using for roughly the first half of the course. The second half has something called first order logic, which builds upon predicate logic. The book uses the term FOL for first order logic for the whole book, but strictly speaking, what we're covering until the midterm is called predicate logic. So this first lecture on the content of the course is getting into this basic language, and then after this I'm going to be applying this to the first homework. So this video is basically lecture 2 in La Lima and lecture 3. I'm putting them together, yeah? So we have the basic ingredients of this simple language. Think of it as learning a new language. Speaking of languages, to help situate what we're talking about, there's a distinction made between what are called artificial languages and natural languages. Natural languages are things like English, Chinese, German, you name it, right? Things that we naturally speak. They're languages, and it's named after various regions and whatnot. Artificial languages, by contrast, are languages, but they're, well, artificial. They're not naturally spoken. Mathematics is a good example of an artificial language. A better, perhaps, example is the languages that computers speak, that you learn in computer science. Various sorts of computer languages like Java, C++, Lisp, you name it, yeah, Pascal, for any who have exposure to that. So the question is, what makes this artificial language a language? Well, to figure that out, it parallels natural language. We have to first figure out what it means to talk about sentences. And in order to talk about what we mean by sentences, we need to figure out what are the components of those sentences. So we're starting from the ground level here to talk about the basic ingredients that get put together to form what are called atomic sentences. Okay? So keep that in mind. We're talking about basic ingredients, and then we're going to put them together. The two ingredients you need are what are called constants and predicates. Constants are basically subjects. Like for any English sentence, if we've got, like, for example, where's the here? John goes to the market. That's an English sentence, right? What's the subject of the sentence? John. So in our language, that would be denoted by the lowercase letter j. Yeah? That's a constant. And then the remainder, goes to the market, is the descriptor, right? So you have subjects and what are called predicates. The predicates are the descriptor phrase. In this case, goes to the market would be the descriptor phrase. And so breaking this down, we have a symbolic way of representing this natural English sentence into our language predicate logic, which would be, say, M for goes to the market, and in parentheses J for John. Okay? Once again, constants are denoted by lowercase letters. They're usually at the front of the alphabet, A, B, C, D, etc. They vary. They are contrasted with what are called variables, which are very important for the second half of the course. They are denoted by the end of the alphabet, U, V, W, X, Y, Z. They're basically placeholders. Don't worry about it for now. And then on the other side, we have, besides constants, we have predicates to describe what's going on. So in our language, in the language of logic, we're going to be using a very restricted language that Tarski's world and the other programs are getting at. And we have three kinds of objects. We have, if you remember from last lecture, we have tetrahedrons, three-dimensional triangles, dodecahedrons, or dodex, soccer ball looking things, and cubes. These are some of the predicates. So the descriptors in these cases would be like, is a cube, is a dodec, and so on. We can also talk about sizes and relations. We can say large, is small, is to the left of, is between, and so forth. Here's the summary. Constants are lowercase letters. Predicates are descriptive phrases. These two things, constants and predicates, they get put together to form what are called atomic sentences. Okay? Atomic sentences are basically properly combining constants and predicates to form complete thoughts. If I just said A for Alice, that's not a complete thought. If I just said is a cube, that's also not a complete thought. In order to get the complete thought, I need the predicate and the constant, or the predicate and the subject. A is a cube, right? So some examples would be dodec parentheses E, which reads in English E is a dodec. Same size AF, which reads in English A is the same size as F. And then between G, H, D, which reads it's always left to right, G is between H and D. These are all what are called atomic sentences. What makes them sentences? Well, they sound like sentences in English when you translate them. And the second part, what makes them atomic, has to do with an ancient view of what's called classical physics. They have to do with atoms, right? What are atoms? Atoms are the smallest components in general, right? I mean, before modern physics and modern chemistry, where you've got atoms as listed in the periodic table, helium, hydrogen, oxygen, and so forth. Before that, way back, we're talking about, we're talking about ancient Greece, where they didn't have much technology at all. Ancient times, right? You had theoreticians talking about, speculating about the nature of the universe. Democritus was the guy who came up with this and said that the universe is basically formed of atoms. What are atoms? Well, conceptually, he's saying it's that which cannot be divided any further. You might not be able to see it, you might not be able to taste it, hear it, smell it, but they're there. Smallest, indivisible components. Hundreds of years later, thousands, in fact, of years later, scientists come around and say, hey, this guy was right, Democritus. It turns out that the universe is composed of these non-divisible things, these smallest components, and that's what the periodic table is. And you can think of it as like Lego. Lego is these objects that cannot be broken down any further, and yet with it, if you put it together in various ways, it patterns everything, right? What can you do with Legos? You can build a airplane, you can build a ship, you can build whatever you want. That's the point. Likewise, the classical version of physics and chemistry, classical view of science, holds that everything in the known universe is composed of these atoms. So what is everything? You and I, the air we breathe, our thoughts, the feelings we have, the universe at large, the earth, everything. It's just matter in motion. It's atoms put together to form molecules, molecules put together to form macromolecules, and then everything is just the pattern of these various kinds of combinations of atoms in motion. Yeah? So likewise here, if those are the basic units of the universe, what we're talking about here are the basic units of meaning. Atomic sentences are the basic units of meaning that can't be broken down anymore. E is a dodec is one basic unit of meaning. I can't break that down anymore. If I just say is a dodec, that's not a complete thought. If I just say E for Elaine, that's not a complete thought. So this is a complete unit. And then from that, when we build upon these atomic sentences later on, we're going to get what are called molecular sentences, putting together more complex kinds of thoughts. Yeah? Here are some examples of things that look like atomic sentences but are not for various reasons. Cub X, it's just like in English. This is not a sentence because there's a spelling error. Correction, cube, and you need a constant. X is a variable. You have to have a constant in order for it to be a sentence. Tet, it looks like A, missing parentheses. That's like a punctuation error, missing like a missing period in a sentence. So that's it right there. Between BA, the problem there is everything looks well spelled correctly and parentheses are there, but the logic of this is not correct. If you read this out in English, it says B is between A and what? There's a missing third thing. If you say between, it needs three and exactly three things, no more than three, to talk about between. This is between that and that, three things. That's its inner logic. Likewise here, suppose you wanted to say A is a large cube. You can't be embedding this in that other thing. So you'd have to separate them out. There is a way to say A is a large cube, but we're going to learn that later. The components of A is a large cube is, first off, A is large, and secondly, A is a cube. Okay, so that's the end of the first part of this lecture dealing with homework 1. That's the conceptual background. Now let me get to the actual materials. So they have in La Lima, again, you should be doing the reading and all that on your own, but this is the video version of this, so I'm going to go through it more quickly and somewhat less carefully. Let's get to the homework. So this stuff I have up here, I'm going to apply it when I get to the homework. For homework 1, remember they go hand in hand with the book, so make sure you open, after you do the reading, again, you don't have to do a great job, you just have to skim through it, get a sense of what it's saying, try the U-Trites if you have time. Spend most of the time with my lectures and their materials, the videos and whatnot, to work the exercises. That's where you want to be spending most of the time. So for homework 1, all of these exercises are in the book, and I'll be taking you through that, yeah? If you've got the E version, here's the book. You go to chapter 1, Atomic Sentences, after you've done the reading, and you'll find at the end there's the numbers. the exercises. 1.1. So if you look at the syllabus, always follow the syllabus because it indicates following directions. That's part of what logic is about, learning to follow directions, learning to discipline yourself and your mind, your being. If you miss any of the you try it on your own. Now for 1.2, which is really the first part of the exercise that you'll be turning in, it's basically just create a file where you add in all these sentences that are listed in 1.2 in the book. So you have to launch Tarski's World. Okay. Just wait for it to launch. You launch Tarski's World. That's why in the other previous lectures before, I said launch this stuff, make sure it's working. Now we're going to be applying it. And you basically just literally enter in these sentences. This first homework assignment is just about trying to get familiar with the software and all that. Okay. So here it is, the sentences, and here's Tarski's World, yeah? The first one is A is a tet. So you click here. Don't type it in manually from the keyboard. That's going to get you in trouble. Try to use the palette as much as you can. So you click on tet, then you click A, and that's the first one. And then after that, you don't hit enter or return. That's not going to work for you. Again, this is about getting familiar with the program. You play with the buttons here. There's add after. That's the one you want. And then you add the next sentence in. Medium A. This is in our language, predicate logic. What this translates into English is that A is a tet, A is medium. But don't worry about that for now, okay? So do that, 1 through 10. After you do that, you go to File, and you save as. Always choose Save As, the relevant type. In this case, it's a sentence file. You save it as. Save it on your desktop so you don't lose it. And where do you save it? Besides, what do you call it? You call it sentences, and then it's named always after the file that you're working on. In this case, it's 1.2. So you save it, saving as, sentences 1.2. After you do all 10 sentences, you enter them in. You're good. Now, the next one, 1.3, is a little bit more complex. It says, now you build a world in which all the sentences in 1.2 are simultaneously true. Okay? I actually have a video, well, I have something taking you through this that you should do it and read that in the lecture. Those links there are important and you should actually get familiar. Don't rely just on my video here, but try to use the other materials elsewhere. But for this first homework, I'm going to go through it really quickly, okay, to show you how it's done. So we want to make 1 through 10 true right here in the world. So the first one says A is a tet. So I click on that button up there. It's always a cube coming down. Click on it, highlight it, click on the tet, name it A. Okay? The second one says A is medium. So that's the same A. These are the sizes right here. So I click on that, it makes it medium. The third one says B is a dodec. That's a new object. So I click on a new object. I make it into a dodec. I call it B. 4 says C is a cube. I need a new thing. There's a cube. I call it C. 5, now we're getting a little more complex. 5 says A is in front of B. Front of is anywhere in front of. So if I move B back here, A is still in front of B. If I move it, say to the right all the way down there, A is still in front of B. Think of this as like each of these is rows in a movie theater. A is sitting in the front, in the row in front of B. B is in the second row, A is in the first row, yeah? So you can play with it, move it around. 6, A is between B and C. A is between B and C. There's A, there's B. To have it between, there is a restriction in our language. Between means, think of tic-tac-toe. If you have tic-tac-toe, it means they're all on the vertical, or all on the exact same horizontal, or all on the exact same diagonal. So if I moved A something like that, whoops, I move B back, move A somewhere over there, and then I have C over here, and I look at it, it kind of looks like A is between B and C, right? But no, you have to have them exactly on the same, let's say, diagonal or vertical or horizontal. So let me move them all on the diagonal here, and in that case A is between B and C. When you make any change, you have to keep in mind where you've been to keep that information consistent. That's part of what logic is about. It's an exercise in memory, where you've been, how you put information together, does it make sense, is it coherent, and so forth. This is a good exercise, by the way. Exercise in coherence, whether things make sense. There's this recent study saying that students nowadays, they believe fake news is real and they can't distinguish it from the real news. And in fact, when they were given options between fake news and real news, they thought the fake news in certain cases was more reliable than the real news. There's a lack of ability to see coherently what makes sense, what doesn't. How do you fact check? How do you see if this thing is real or not? Logic is partly a beginning study in learning to think more critically so you can filter through complex information. That's a good skill to have, especially when presidential elections are largely determined on things where there's so much misinformation around and people believe these things. It's not just the US, it happened in the UK as well. Brexit. A number of people thought it was good for them. They didn't realize what they voted for. It turned out after they voted for this thing, a whole slew of people, the very people who voted for the UK leaving the European Union, a whole slew of people actually had to Google Brexit to find out what exactly it was that they voted for. That's illogical, and it has consequences. So, keeping that in mind, logic is not an impractical study. It looks like this has no use for your life whatsoever, but the analogy I often use is it's like lifting weights with the mind. If you try to strengthen your mind, it has other benefits elsewhere. But you don't see that in the short run. All you see is this stuff is difficult, I'm having a hard time. So it's crucial in logic to keep at it. It's an exercise in not just self-discipline, turning in work on time, learning to read a syllabus, following complex directions. It is crucially, above all else, an exercise in perseverance. Stick with it. You fall down, you get back up. You fall down, you get back up. That is logic. Learn to stick with it. Don't give up. Keep trying. Okay. So A is between B and C. There's A. It's between B and C. The next one says A equals D. This is tricky. What equals means in our language is it's one and the same. Think of them like pen names. If I say Mark Twain equals Sam Clemens, that's saying they're one and the same person, right? Or if you want something from comics, since everyone pretty much knows that, Batman equals Bruce Wayne, right? Superman equals Clark Kent. They're not differing people, they're one and the same. That's what equals means. One and the same, but two different names. So if I got A over here, to show that they're one and the same, I click on the D as well, and that means they have two names, Albert and Dilbert, whatever. Albert and Dilbert attached to the same object, right? Now, 8 says A is larger than B. Take a look. Is A larger than B? It already is. A is medium, B is small. Okay? 9. A is smaller than C. Is that true? Is A smaller than C? No, C is small. So since A is medium, the only option for C is large. It has to be. And then lastly, 10, B is to the left of C. Oh, it's not. B is to the right of C. So how would I rearrange things but keep all the information intact? How about I move C over there? Okay, let's move B first. Move B on the diagonal on the opposite side. C over there, switch it around on the diagonal, and there you go. Now you've got all 1 through 10 true, and what you can do is you can verify this after you've created 1 through 10 in sentences 1.2, and you choose this up, you play with the buttons that you got up top in Tarski's world to get a feel for how to verify them all, and you should find they're all true. Okay, once you do that, you go to Tarski, File, Save, and remember, you always choose Save As the relevant type. In this case, not save sentences, it's a world you just created, so save world as. Save it to your desktop, call it world 1.3, and you save it. Okay? So that's that. That's 1.3. For 1.4, I have this laid out in my lecture in La Lima. I want you to read that. It also has some video to guide you in case you get stuck. If you understand 1.2 and 1.3, now it's time to try a little bit of 1.4 on your own, but if you get stuck, I have the video and other guidance there in La Lima. You should use that I'm going to go back and forth. Don't rely just on my videos. It's not sufficient. Okay? So that's 1.4. Next we have 2.1. And 2.1 is slightly different. 2.1 is now talking about arguments and using the concepts of validity and soundness. So here's 2.1. This is mainly a conceptual exercise, and you only have to turn in one thing. That's the invalid argument for argument 5. Okay? In my in my lecture in La Lima, I go over this as well, and I explain each of the arguments and how it works, and I cover that also in the audio file. I want you to get familiar with that as well, so you understand what resources are available to you. Again, go there, use the audio file in conjunction with the picture files. Yeah, they're separate from the lecture, and it will guide you through what to turn in here. And then the last thing to turn in is 2.2, and I have also in La Lima a Word document file going through what you need to fill in right here. Here's 2.2 in the book, and we're applying these same concepts, validity, invalidity, to plain English type arguments, but it's the same underlying logic. Even though we're talking in our language with Tetsa and medium and so forth, and here they're talking about Harrison Ford and right to bear arms and so forth, same underlying logic, just to show you that logic applies to any number of things. It's not dependent just on the language, but on the reasoning that the language uses. So 2.2, I have a Word document, and you're going to turn that in not by the grade grinder, but you're going to submit that as an attachment via email. Again, look through the lecture I have in La Lima that will guide you through this. This video lecture here is just an initial estimation, an initial guide, but you have to use those other things to help you out in terms of the details. Okay, the last thing I'll cover really quickly is how to submit your work. So once you've got all your stuff saved, okay, what you're then going to do is you go to submit, and this is the only time you use submit, is to turn in work. You enter in all your information as I showed you how to get registered with the grade grinder, and then you choose files to submit, and then you find it. It should be, again, save it to your desktop as I told you before so you don't get lost. So if you're a Mac user, go to slash, go to your desktop, or where should, well, okay. It should be there. Oops. I don't even know. Oh, this is a good mistake. Right here. Go to, okay, Mac users. So if you go to slash, that's everything. If you click on this, that's your personal drive. And under your personal drive, there's going to be desktop. And then you should see everything that you have there. I saved it to the desktop. PC users, you just have to click desktop. The first thing to turn in is sentences 1.2. And then after that, we had world 1.3. So you double click on it, or you can click highlight and choose add. And then you should also have world 1.4 and sentences 1.4. That's 4 files so far. And then lastly, world 2.1.5. Okay, so there's 5 files to turn in. You should have 5 here. You click done. It pops up in here. You submit files. You never ever submit it straight to me first. You always choose just you. You click OK. It sends it through, and then you check your email that you registered here in your email address, and then it'll give you feedback. It'll say what's right and what's wrong. You need to get at least 75% of each package correctly to get the 2 points. 2 points is the max you can get on every homework. Yeah, you should all get the 2 points. Here's the dirty secret. I alluded to this before. The course is set up so that if you keep the pace of things, and if you get perfect homeworks on all the homework, it becomes almost impossible not to pass the course. The homeworks are the key to this course, and since I will be doing most of the homeworks with you, nearly all of it in fact, you should learn how to think through this stuff and make sure you get it in on time. That's part of the discipline of self. Learn to turn things in on time, not last minute, not late, but try to get it on time. If you turn in late work is accepted, but it gets docked 1 point. So make sure you get the 2 points every time. To get 2 points, you don't need 100% of the package correct. You just need about 75. What does that mean? So if there's 4 exercises for the package, 75% of that, like 4 quarters, is 75 cents. It's 3 quarters, right? So if you get 3 of the 4 correct, that's enough for 2 points. That's why you submit it just to you. You check your grade report. If it looks like you got most of them correct, you have to have 3 totally correct out of 4, but 1 you got wrong. Then you've got the 2 points, and then you can go back and choose me, instructor 2. If you choose just you and you got mistakes, you can go back and correct it and resubmit it to yourself as many times as needed to make sure you're past that 75% bar to get the 2 points. Okay? So make sure you do that to get the full points. When it's ready, make sure you choose instructor 2. That should only be done once, and you should turn it in as one complete package. I don't want it in pieces. I get a lot of emails. Make sure you turn it as one package so you get the credit you deserve. One package. So there should be, in this case, 5 total. If you want to get the 2 points, you need to turn that in, plus separately the 2.2, which is the file to be turned in as an email attachment. You need roughly 3 or 4 correct of that total package to get the 2 points. Okay? Alright. Seems like a lot, but this is good exercise in learning, in pumping your brain up, learning to follow directions, and all that good stuff. And as always, if you have questions, you can email me at any time, and I'll get back to you relatively quickly. Alright folks, good luck.